Okay, this is a video to show how to find the sample size when we're working with a one proportion sample mean. So this problem is the battery problem, example 2 from chapter 23. So we've done a hypothesis test and a confidence interval, but now they want us to find the sample size. So they're suggesting that we use a 95% confidence interval with a margin of error. They don't say margin of error, but they imply it. So they imply they want a margin of error of plus or minus 15 minutes. So let's recall that the confidence interval is an estimate plus or minus the margin of error. Okay, so the estimate is x bar in this case, and then we're going to use t star of degrees of freedom, some specified degrees of freedom, times the standard deviation divided by the square root of n. So this is our margin of error. So we're going to say we want a margin of error equal to t star of df sx divided by the square root of n. Okay, so now we can just kind of plug and play a little bit. We want the margin of error to be 15 plus or minus. Let's just wait for a second on this. So if you recall, the standard deviation was of the sample was 29.31 divided by the square root of n. Now here's the problem. What do we use here? Okay, well, what we want to do is we want to say t star equals inverse t, and we want to give it a value. The alpha value would be 0.025, but this function we have to provide the degrees of freedom, and the degrees of freedom is a function of n. So we're kind of in this little vicious circle. We're trying to estimate n, so what do we do here? So the shortcut is to say, well, let's start with a crude estimate. Let's use z star. Okay, so we'll take 15 plus or minus, and at a 95% confidence interval, that implies a z value of 1.960, you may recall. So 1.960 times 29.31 divided by the square root of n. Okay, so if we solve for n, multiply everything by the square root of n times the square root of n, divide by 15, divide by 15. So this cancels, and if I keep saying equals. I don't know why I do that. Somebody should have spoken up. Okay, this should be equal. So then if I square this, then I have to square all this stuff, right? So I get n equals 1.960 times 29.31 divided by 15 squared. And if you punch that into your calculator, you're going to get 14.67. So a sample size of 15. So now that we know that, let's go back and say that implies degrees of freedom equals 15 minus 1 equals 14. So now we can go back to this calculation up here and say t star of 14 equals inverse t of 0.025 of 14, and that's going to give us 2.145. So we go back to our calculation. We can go all the way back to here if we wanted to. Alright, and we have, I guess I'll just do this one more time. Margin of error equals T star of df times sx divided by the square root of n. Now we have a better estimate of how many degrees of freedom. So we have 15 equals 2.145 times 29.31 over the square root of n. So if we solve for n this time, we get n equals 2.145 times 29.31 divided by 15 squared, and that comes out to be 17.56. Okay, so we would need to sample about 18 batteries to estimate the mean battery lifespan. To within 15 minutes with a with 95% confidence. Okay, so that's how you do that. So you have to kind of exploit Z a little bit. Give it a try. Good luck.